Hey everyone, how are we doing? Make sure we don't have the video playing in the background. Oh, there, paused it so you can't hear it. How's everyone doing? I saw some people were in the chat. Let's wake up Mewbot. A little bit of a late start today, but we had some meetings, so we're here now. We got James in the chat. James, are you still here? You said, can we go over homework 1, question 6? So we got the first question of the day. It's a new week. Whoa, that even scared me. Which button did I hit on the music? Oh, it's a sound effect. Oh my gosh, scary sound effect. It's called fire. Wait, that's not... What is going on? This one. Oh, Mewbot's awake. If you're here, say hey. What do we got going on? We're just... I was like, what is that? Whoop, whoop. Hey, Kaya, good to see you here. We're going to start. I was going to play some music. And then I hit the fire button. So I just had a bunch of random noises. Craziness. Trying to get... Okay, I think we got everything fixed up. Hey, Mooscan, good to see you here. What are people working on? What questions do people have? I'm going to pull up the 474 homework assignment 6, or question 6 assignment 1. That was the first question of the day. Need to get the homework up. Question number 6. I need all the coffee in the world. All the coffee. Looks like a subset. Question 6, making subsets. Eating a pizza pretzel from Aunt Annie's as my reward. That's awesome. Congratulations. Pizza pretzel's good stuff right there. Let's do some question 6. BA is 474. Homework 1. Question 6. Let's go check it out. Here we go. Okay, so let's get going here on this question number 6. We only got a little bit of time for office hours, but let's do it. Okay, so this is how to make a subset. So when we're making subsets, subsets work the following way. I'm going to take out that chunk right there. It's got a HTML thing. I don't want that in there anymore. So let's go right here. And we're going to go right here. And we're going to work with the... Let's go with the MT-Cars data set. So the MT-Cars data set is a data set of cars. Once again, I'm doing similar but different work. And you can see the data set right there. It's basically an Excel spreadsheet. So once again... Brian does similar but different work. So I don't do the exact work you're doing. I do similar but different work. So don't like type everything I'm typing. Think about how it relates to your question. If you look at this right here, it says create a subset called sub. So that means we're going to store into an object called sub. You can do that, but we're going to store into it. Now, to create a subset, you have to call the subset function, which is subset, and what you want to subset. Now, the MT-Cars data frame, I'm going to store it in here as empty cars so you can see it, and then run the sub also. It's no longer, it's the same, but it's a subset, quote unquote, because it is just a subset of the full data frame. So when you take a look at this right here, we now have some conditions. So we haven't done any conditions yet. We're just saying take a subset of empty cars, which it's just going to take the full data frame because we don't have conditions. So if you add a comma right here, you'll start adding conditions. And please do this. If you're following along, run your code. You don't have to run this. This is me just creating an object. If you're following along with what I'm doing, which is not your answers, you would create the object you want to subset or have the object you want to subset. You should already have it as the movies database, which you should see right up there as the movie database. So you would subset the movies. You wouldn't store movies into movies, though, because movies already exist. So anyways... we are going to now go right here and add a condition where we say miles per gallon greater than 18. If you take a look, our subset dropped in size, and this is some of the key things you want to notice, is that when you are subsetting and you're adding conditions, you will originally have the full data frame if you don't add conditions, and then if you add a condition like horsepower is greater than, gotta look at horsepower values, horsepower is greater than, let's say, 98, or greater than or equal to, now you drop in size for your subset. But what if we want to add another condition? We're going to add an and right here. If you notice this sub-indents, and the reason it's sub-indenting is because I'm still inside of the conditions. So it's saying take a subset of the MT-Cars data frame, have the horsepower be greater than or equal to 98, and we want the weight. No, I don't know weight values. Miles per gallon greater than or equal to 20. So now if you notice, we're down to just 5 cars right here. So right now we've taken a subset of just 5 cars. But let's say it says return a certain amount of columns. Well, that's not conditions to return certain columns. That is the select argument. So to do a new argument, we have to do comma. That's why we're doing a comma right there, is we're leaving the conditions argument. These are not 2 separate arguments. They are a kind of set of arguments in the they're an argument in the condition argument and different conditions. So we have condition 1, horsepower greater than or equal to 98, and condition 2, miles per gallon greater than or equal to 20. So now when we get here to the next argument, because we did another comma, you notice the indent went back here to the start, saying that we're not within an argument. We're starting a new argument. We have select equals, and then we do a vector of information, and these are the names of the columns we want to select. So I'm selecting miles per gallon, weight, and horsepower right there. And if you notice, we no longer have all the columns. We have 3 columns. Let me show that again here if you missed it changing. Here's the original right here with 11 columns. And what does select do? Well, when you do select, you no longer get all the columns. You only get the columns you're selecting. And you can see right there, and we even select them in that order. So we could change it to weight, horsepower, and miles per gallon. I've never tried selecting one twice, but now it puts them in that order. So those are the columns we are selecting when we are subsetting, and we can also define the order. So this is a subset of the empty cars data frame with cars that have a horsepower greater than or equal to 98, a miles per gallon greater than or equal to 20. But what if it said it wants the cylinders to be a 4 or 6 cylinder car? You can look at the values of cylinders by just printing the empty cars data frame. And you'll notice the value of cylinders has values 4, 6, and 8. And I think there's a 5 in here somewhere. I swear there's a 5. There's like 1 5. Or I've gone crazy. Table, empty cars, cylinders. Nope, there's no 5. There's no 5-cylinder car. Don't know why I think there would be one. But let's say we wanted the 6 and 8 cylinder cars. Well, we could do cylinders is contained in the vector, and then we'd have to put 6, 8. I think it doesn't matter if we put it in quotes, but these are numbers, so I'm not going to put them in quotes for the time being. And now we're saying the cylinders of the car is contained in the vector 6 or 8. There's other ways by doing or. I wouldn't suggest that, but now you want to take a look at your subset. And looking at your subset, you should see, and we probably want to look at cylinders also because we subset it on that. So let's add the cylinders to the end of it. And now let's take a look. We have 6 and 8 cylinder cars. We have horsepower greater than or equal to 98, and you can see it right here. And then we selected those columns. So making sure your code returns what you want is very important. Hopefully this makes sense right here to everybody, but this is how to do subsets. Are there more questions? 201, Chapter 2 quiz, Canvas content, visualization number 2. What are people working on? I know we got a little bit of a late start today. Sorry about that. But what are people working on? Print the subset. Should have this right here. Print the screen, the sorted sub. So now if you want to sort it, So to sort a sub, you want to take your, I wonder if I could just do this. Watch this. Let me see if this works. Let me go to sub. Here's my subset. And I think, let me arrange it by miles per gallon because that's out of order. So let me go arrange. I think it should be this, right? And can I put MPG? There we go. No, it didn't do it, did it? No, that's not arranging by MPG. I thought that would. Let me try not in quotes. MPG. Ooh, look at that. That's got it. Decreasing. Is it rev? After this, can we go over 474 question number 4? Yeah, Leanne, of course, you bet. I thought arrange had one more argument. And then range. I want to look at arrange. I just want to do it in reverse order. Descending, decreasing. What is that? This one's already worked on already. Lost my spot. So it should be. That's got it right there. That's one way of doing it. That's probably my favorite way of doing it. To use dplyr methodology, you have to load your library dplyr. Make sure to install it if you haven't done it. We're going to like question 4 next, coming up here. The other way is going to be to do the order, and you want to take the order of your sub $sign. We're ordering MPG, so there's the order of it, and you could call this order right here. Do it in a few steps. And then you want to go to your subset. You want to go to the rows and order the rows. And if you notice, it's not in decreasing order. So here we had an argument decreasing equals true. And now it's got the same result. What is dplyr? Dplyr is data manipulation. It's, what does it stand for? It stands for, it's a package that lets you work with data, a grammar of data manipulation. So it allows you to like sort data, it allows you to subset data, it allows you to filter data, to select data. So I could have done this whole question, or this fake question I was doing with subsetting this. I could have done it with dplyr methods to say empty cars, pipe into filter horsepower greater than or equal to 98, pipe into filter cylinder. We're just going to copy this right here. And then filter into select, select those columns. I think we just type the column names. Do they have to be in quotes? It's tough when you change syntax. There we go. That's filtered it right there. And then last but not least, we're going to arrange. So we can actually just take this right here and put the arrange at the end of it. And so this right here is the exact same thing. So that was just kind of a quick way of doing it. I try to practice my dplyr, and the pipe passes it into the next thing, like take empty cars, filter this, and then filter this, and then select this. So it's just passing it into the next thing and doing another set of functions on it. So it's each time believing it has the next object. Like if we were to take something like the vector 1 through 100 and pipe it into mean, it's going to take the mean of 1 through 100 because it says take this and just insert it into here. That's what the pipe does, is it passes it along to the next thing. So each time it's kind of handing it off. It's saying take empty cars and filter it here, then take what you filtered and pass that into the next thing here. Does that make sense there, Kaya? This is kind of a more advanced way of doing it. Really cool to start practicing with dplyr if you haven't done it. And data camps are a great way to learn about dplyr. You might see me use a little bit of it. The pipe is super helpful to like pipe something to the next function. But this right here, filter this, and then filter this, then select this, then arrange by this, and then so there's the full answer right there of what we want. And then we could just take right here and store this into sorted sub, and then the sorted sub has been created right there at the end of it. Yeah, it makes sense because especially if you're like debugging stuff, you can see where each thing is at. Like here's where I filter this, here's where I filter this. It's a little bit easier than looking inside of here because each function like says what it's doing. Like take empty cars, filter this, then select this, then arrange by this. It's a lot easier than that, I think, which would have at the end of it the order right here, because like what does order do? It's much simpler, I think. Personal preferences. Good questions. Here we'll do a break in the video. And Leanne's question, you got it. I think number 4 has a lot of parts, right? Which one do you want to talk about on number 4? Leanne, which one do you want to talk about on number 4? Because I think it has a lot of parts, right? So BA is for sound default. Homework 1. Question 4. Which one are we going to do? Let's start with the main screen. Question 4. Oh, it's got a lot of parts. A and E. A and E. Thank you so much, Leanne. A and E. Okay, A and E. Good ones to pick right there. So the first one says, which row contains the largest value of budget? Now, there's a lot of ways to do this, but when you hear which, that's finding position. Which finds position. Like if I say here, we're just going to add some code in right here. Which finds positions for us. Like that's what a which does. If we go to empty cars and we go to miles per gallon and we want to know which car has a mile per gallon equal to like 3.9, we could do this, and that tells us trues and falses. And if we put it inside of a which right here, we could find out which one has a miles per gallon equal to that. Now we could go and look at the max. Like I could find the max. This is the long way of doing it. I think that was the max. I hope it was. Empty cars. We're using a different data set, remember. Okay, so that is the max. So I could actually store this as a value of X. And then I could say which of these is equal to that value. And it's row 20. And we could also find that a lot of different ways. But watch this. Which dot max? This tells us the position of the max. It says, where is the max? So if I go to which max, empty cars, and miles per gallon tells me that that one right there is where the maximum is at. So which max, which min tells you the position, like in the data frame. If you look at your data frame, it tells you which position. So position 20, which is right about, oh, I lost it. Position 20 is where the maximum's at. There it is right there. Position 20, the Toyota Corolla. High miles per gallon. Does that make sense, Leanne, right there? Which min, which max tell you the position of the mins and the max. Super quick way right there to get the answers to questions like that, where it says which row contains it. Just take the vector of information and say which max, which min, and we should be able to get it right there. And once again, Brian does similar but different work. Brian does similar but different work, showing like examples. Yeah, no worries. It's a super quick function. Like the long way is to do this. Don't do that. The quick way is to do which min, which max. Super quick. What fraction of a numbers exceed 50 million? Do this with a comment. I don't like this methodology right here. I just like to use a mean on a logical statement. So let's take a look right here. And Liam, we got more than enough time to do a few more after this. I know shorter office hours today, but let me double check. I start class here in a little bit. Yeah, I start class in 12:55. I'm gonna grab some coffee after this. So let's go ahead here and drop this in. Drop in a chunk so we can do our code right next to this right here. Now, we want to know, let's say this. What fraction of cars get a miles per gallon more than 30? Okay. How would I write this out to do from my empty cars data frame, miles per gallon more than 30? How would I solve this with the finding for the miles per gallon more than 30? Always do this in steps right here. Don't do the full thing. So how would I solve out to find out if the miles per gallon of my cars are more than 30? Just that. Don't worry about the full thing. I just want to see if my miles per gallon of my cars are more than 30. How would I do that? How would I see if the miles per gallon of my cars are more than 30? We haven't thrown any points today. Mubot's awake. We haven't thrown points. I need more coffee. How would we see if the miles per gallon of a car is more than 30? What do you think? So you want to check empty cars, miles per gallon is more than 30. And you do a logical check. How would we do that? Not quite which yet. Not quite which. So and Leon, you're on the right track, another 100 points. Just from the empty cars data frame, we want to check the miles per gallon of a car is more than 30. That's all we want to do. Just that. But no which yet. So how would we do this? Go on the right track. How would we check the miles per gallon of from the empty cars data frame is more than 30? Pretty much. Well, where X is the empty cars, so we would have to have it stored into X. I see what you're saying right there, Leanne. That's pretty much right. So if we have this object X, then we could check which X being this right here. Like this is X. I mean, it's not X right now, but if this was X, then we could check right here if it's greater than 30. I think you're using X right here for this or something, or you could store it. Does it say store it as X? It's boxed right now or something like that. Okay. So with this right here, we could check if it's greater than 30. Okay. So I wouldn't put a which around it. If I put a which around it, it's going to tell me the what's of the what's. And I don't know is a great answer, or taking a guess is a great answer, worth 100 points for any guesses or answers. If I put a which around it, which I don't want to do, but I'm going to do it, it's going to tell me the what's of the what's. Oops. If I put a which around it, it's going to tell me the what's of the what's. Kind of gives some hints right there. What's it going to tell me if I put a which around it? Which I mean, I'll run it, but I wouldn't do it this way. What will a which do? A which will tell me the whats of the whats. More callback. A which is going to tell me the whats of the whats. The positions of the perfect answer. That's exactly the way I phrased it. The positions of the truths. If you notice, that's where the truths are at in position like 18, 19, 20, and there's another one up there, 28. So those are the positions of the truths. I wouldn't do that because trues and falses are just seen as ones and zeros inside of R. So like all these right here are just ones and zeros. Does that make sense? Like every value right here is just ones and zeros. So if I were to view this another way right here, this would be, it's pretty much R is seeing it like this right here, ones and zeros, right? So I could just find the what of this vector to find out the percent of truths. 4-letter word. Instead of doing which right here, instead of doing which, I could just find the what of this vector because it's just a bunch of ones and zeros. So I could just say, what's the what of this vector? Because that's where the truths are at. They're at where the ones are at. So I could, if I wanted to find out the percent of truths, I could just take the what of this vector. Hint, I could find out how many truths by doing the following, because they're ones and zeros. There's 4 truths. So there's a lot of ways to solve this. I wouldn't do this way, but this is an answer to the question. So this is the answer to the question, but think about what that's doing theoretically by saying there's 4 over this many. I'm just taking the what of the vector. 4-letter word. I'm doing the long ways of solving it first. So which, length, which, I wouldn't do this way. Yep. So I could just take the what of the vector because I'm just dividing by how many there are. I'm saying there's 4 truths, divide by how many there are. I could just simply take the what of the vector. Instead of doing the sum, 4-letter word, I could just take the what of the vector. Because remember, it's just truths and just ones and zeros. So I could just say what percent of 1 there is by taking the what of the vector. So what could we do? Just take the, give it a few more seconds here. Hint, on average, but 4-letter word. Hint, on average, but 4-letter word. So on average, but 4-letter word for the 100 points right here. So we are going to tell it to take the average. What we're going to do with a 4-letter word. Mean, you got it, Leanne. Great job. Yep. There you go. So that's the quickest way to do it right there. These ways are much longer to find out like how many truths there are, then divide by how many things there are to find out the positions of the true, the length of the positions of the true, the length of the vector. It all arrives at the same answer, but the quickest way is just to say, well, let's just, you know, they're a bunch of ones and zeros, so let's just find out the percent of truths. We don't want to find out, it's just unneeded to find the positions, the length of the positions vector, because this will just return 4, which is how many truths there are, because it's returning the length of the positions vector. So that's the positions of the true, and there's 4 elements in there, so it's returning the length. I wouldn't do it that way. Are there other ones you're working on, Leanne? Let me know. I'm going to head over to the main screen. What other ones are you thinking of? We got more time here. Do about 10 more minutes at least. I know today was a little bit wonky office hours. Do-do-do-do. Oh. Whoa. That's cool. Cool email. What a H. What up, Alexander? Good to see you here. Thank you so much for all the messages, Alexander. Keep it up. So we got H. A, B, C, D, F, G, H. What is the average value? Let's go check this out here in a moment. Doing a trick. Okay. Let's go check out H. Here we go. So once again, remember Brian does similar but different work. Brian does similar, different work. This is BAS 474, homework 1, question 4H. Okay, so it says you're looking at the tomato meter. If all the entries that are 999 are a bogus value or NA are excluded. Okay, so with this one right here, and the issue is we have 999s that need to be excluded. So frankly, what I might do is you could exclude them. So let's say we have something, let's go bogus values. So bogus values are going to be values that are, let's say if a car has miles per gallon equal to 21 or NA. So now I want from the empty cars data frame, I want the value of, let me go to empty cars data frame, miles per gallon, and these miles with the bank loop. Do we need to compute interest like, oh yeah. I mean, good questions, Alexander, right there. Good questions. Are they contained in the bogus values? Okay. So are these the things I want or don't want? Are these the values I want or don't want? Are these the values I want or don't want? So I want you to look right here. I said the values of MPG are contained in the bogus values. I don't want, right? So this is something we brought up in class right here. The problem right now is the trues and the false are reversed. So these are the things I don't want. So how could I quickly change this to things I do want? So you see how like it's like trues are where I don't want those things. It's true that I don't want that. So how could I quickly just instantaneously change these really quick? How could I change that really quick right there? How could I change that really quick? Now I could recode things to NA, like I could recode the 999s to NA. That's one way to handle this with your original problem. But how could I change these to things I do want? I have identified here what I don't want, but how could I identify what I do want? So one little trick right here, quick change that we talked about in the morning class today came up. It's a very quick way to change trues and falses inside of R. Very quick way to change trues and falses. I don't know is all his answer if you don't know. So there's a very quick way to change trues and falses. Like you can take a true and make it false like that. And the way to change trues and falses, all of them, is to just add a exclamation mark in front of your vector. So now you see where it says true, true, false, 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 false. Now it says false, false, true, 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 true. So all the exclamation mark does is flip your trues and falses if you look at the two codes right there. So exclamation marks are a quick way to change a logical vector from all true or trues to falses, falses to true, vice versa. Does that make sense, Leanne, right there? So we can easily change a logical vector from true to false or false to true by doing exclamation marks. So it just flipped everything. Very, very powerful to just say, well, I do want this or I don't want this. So let's just flip the vector. So now these are the positions right here of the things I want. So now all I need to do is go to empty cars data, go to the miles per gallon and go to those positions. And those are the positions of the values I want. And then I just need to do what? Does it make sense what I do from here? So now I have the positions of the things I want. I'm not taking the full vector. I'm just taking the positions of the things I want because I don't want the first or second. It's false that I want the first. It's false that I want the second because they're in my bogus vector value. So I can look and make sure I have this. I would just need to take the what of this. I could call this X if I wanted. And that would just be the vector of information I want. And then I could simply solve this now by doing what? So I made a vector of bogus values. I saw if the vector I'm looking at is contained in the bogus vector. And then I flipped it. Instead of being the things that are contained in the bogus vector, this says things that are not contained in bogus vector. So contained in bogus vector, but not contained. So this just makes it not. The positions of the things that are not contained in the bogus vectors, the values of the positions things that are not found in the bogus vector stored into X. And then we just take the mean of it and we have the answer. Does that make sense, Leanne, right there? Hopefully this is helping out to see it in steps. Great job. Thank you for being here, Leanne. 100 points. Gonna grab some coffee here in a moment. Let me send out but ask another question if you got it. Because we're gonna send out the announcement to the class saying class starting soon. Class in. I think I'm not caught up on sleep. I had to get up early yesterday. It just like throws your sleep schedule off. Class in 25 minutes. Let me throw a link. Class in 20. Look over main screen. Class in 25 minutes. Okay. Section 4. I have to get to a different class. No worries. I did witch to find position where it's not equal to and then yeah, Alexander, great job. Yep, you found NA not equal to that, found the positions, and then took those positions to just run any. Yeah, totally, Alexander, 100%. Alexander, 100 points again. Great work there, Alexander. That works 100% too. As you can see, there's so many ways to solve these. There's just so many ways to come to the right answer. Just like, you know, you could recode your 999s to bogus values or to NAs because they are. Like, you could just recode it. Like, a tomato meter shouldn't have a 999 rating. So you could just go in and recode the 999s to NAs. So you could do like positions that are equal to 99. You could do movie $ tomato meter equals 999. Go to the tomato meter vector, go to the positions of those, and then left arrow into NA and then remove NAs. So you could overwrite them all as NAs and then remove the NAs. Or you could only get the positions that are not equal to, which I think you did, not equal to 999, and then take the mean of that vector, but do NA.remove on that. Or you could make bogus values and take the things that are not the bogus values. Probably the best way to do it might be to recode them, because then if they truly are bogus, you could just remove NAs and say like, well, these values are ones we don't care about because they are ridiculous values. But that's got it. Amazing work. I include 0 months, 0 in my graphics for the loop. I felt that's a good way to include the baseline. Oh, of course, yes. Alexander, are you almost done with it? Have you already completed like next week's assignment? That's amazing. I thought it was going to be super tough. I should make it more difficult. I'm kidding. No, that's amazing, Alexander. Like, congratulations. If you've already completed next week's assignment or pretty far into it, you are way ahead of the game, and that's awesome, Alexander. Keep it up. Check your Discord for a sneak peek. Let me go check it out. Yeah, I think... Here we go. Let's take a look. Let's see. Yes, you got a picture of it. Nice. Oh, this is the 3 months to pay car loan off. $1,000. Look at that, and you've got the interest. Oh, and you put the numbers above it? That's so cool. Let me see right here. Where's line? Plot. Yep, plot type line L. X lab months, Y lab main. Paste. Yeah, there it is. The months to pay off loan. Oh, and then it's X AIT is N. So what does that do? And X-axis 1 to Oh, you're even doing it. This is insane, Alexander. This is amazing. Text, and then you put the text right there. That is so cool. Alexander, I got to get you on some ggplots. This is top tier work. Like, Alexander, let's throw out some 500 points. This is amazing. That is absolutely amazing. Points, add, plus, viewers. Alexander, 500 points. That is stellar work. Like, that is literally what I'd be expecting from our graduate students. Let me see right here. Is quotable correct? Q1B. No, that's amazing, Alexander. Congratulations. I'm just super proud. Print the screen. Is it find the sum of it? I think so. Yep. Awesome. Replying to people there. Did I compute the dwindling of the car loan correctly? I think you did. Let me take a look at that again right here. I think you did. It looks to be. And then you have it get down to 0. Oh my gosh. And then which min month? Mm-hmm. It looks to be computing correctly. While this is like excellent work, Alexander. And with your ifs right there. Yeah, this is great. This is amazing work. Great job. And to turn this into a function, do you know how to make functions, Alexander? Because to turn this into a function, you could easily just wrap it in a function. You go over homework 1, question 2. Yeah, homework 1, question 2. So question 2 talks about missing data. This is the last one we'll do right here. Let me add this in here, Parker. Thank you, Parker, for asking. Let's check this out. Gonna grab some coffee between class. 3623 BS. I had to convert it to a function. No. Yeah, right. I'm sorry about that. I probably wouldn't have counted off if you did that. Question 2. Let's go to question 2 right here. That's too funny. Like, yeah, I know how to make functions. Real world data can often contain missing values or errors or things like that. I'm gonna go away. Critical skill: by using the concatenated vector, manually type out these. Manually type these out. Really? No, I'm gonna copy paste. If you take this right here, we could take this vector right here and go to BAS or lowercase BAS, store into a concatenated vector, and put the following information. So I'm just gonna code this out right here. Function, I know, great job. They are the best. The cubed root. So there's no cube root function as far as I know. We'd have to raise to the 1/3 power. That's cube root, and then e raised to that power. You can do new lines. Make sure yours doesn't have an error like mine does right here. E raised to this power is exp. That's the function e raised to the power of this. Oh, it's fine. There we go. And then this. Okay, cool. Now go away. Oh, good. So now we've stored the vector. Now I'm not going to do everything in this one right here, but we've created the vector. I prefer to copy paste. Make sure everything creates, and you want to make sure it literally creates like this. If you don't have the vector, you can't do the remaining parts of this. Just say, make sure you see the value. Is going to ask for the sum of it. Wait, where is it? Make sure you see the value of 7 point. So let's run BAS. And there it is right there. There's the value. We should have a sanity check with the sum. But that is the value we currently see. So everything's good. Imagine these are bogus values. This is something we were talking about earlier. We're talking about bogus values and kind of dealing with them and maybe writing into those positions. So the %I and % means contained in. So let's say I want to find out which people in a data set. So similar but different work. Let's say I have from the library reg class, I want to go right here and bring up the survey 10 data. And the survey 10 data has a thing about handedness. So I want to know if people are right or left-handed. So I go here and I ask the question, survey 10 data handedness is contained in, and that's %I in %, contained in the vector right or left. So anywhere I see a true means what? Somebody's handedness is one of those values on the right. Does that make sense, Parker? So by doing this right here, I'm saying this is a vector inside a data frame, just like your vector, like the BAS vector. Is somebody's handedness contained in this? So then we're looking on the right. And so you'll notice right here, ambidextrous is over there at the end of it. So that's why at the very end, the 1, 2, 3, 4, 5, 6, 7, 8, 9, the ninth element from the end, is a false, and that's the one right here because this person is ambidextrous. Now, we talked about this earlier. You don't need it for this one, but if you wanted to find the people who are not right or left-handed, you could just flip it by doing an exclamation mark, and it flips your trues and falses. So just look at without the exclamation mark, with the exclamation mark, the difference of your trues and falses just flipping. Very powerful to just be like, oh, I don't want this, or I do want this. You can just flip the trues and the falses. Super powerful. We're not using that right here, but very powerful thing to do. So this could be single-handed people. So these are the people who are single-handed, like they prefer to use only left or right only. So now if I wanted to like overwrite these people, I could go to my handedness vector and go to the positions in those, and if you take a look, this is only going to return to me the right and left-handed people. It does say ambidextrous is still here, but that's just a level to the vector. These are only the people in the single-handedness positions. It's not returning out the ambidextrous people. And we can show this by storing into here missingness. And now if we look at the handedness vector, there's only people who are ambidextrous. Now the levels still has the other things. We could use drop levels. I'm not going to do that right here, but I'll show it. It's not needed for this question. But if you're wondering why those still exist, if you go and drop levels, it'll drop unused levels. And I think now, and I think it writes into it. No, it doesn't. You have to overwrite it with the dropped levels version. So now it just has ambidextrous. That's not needed, but if you're wondering why is it still showing those, you have to drop unused levels from the levels vector to remove them from just displaying. They're still kind of there as a container, but then we've dropped the unused levels, not needed for this assignment, but I've overwritten left and right-handed people with missingness. And as a factor, it shows missingness that way. That's still just regular old NA. It's just telling you that that is not the word NA. That is the missingness value NA. So now that we've done this right here, so now is two missing values, yeah. So we need to print. I just printed it to the screen. If you want to print something to the screen, you can show it. A bunch of missingness values. But we're going to do a problem right here. Use some combination, print to the screen the positions of the two missing elements. So if we want to present the missing positions, well, is.na lets us know if something is missing. I'm not going to do this full thing, but that lets us know if something is missing. How could I get where the trues are at, Parker, right here? I think we're kind of snowballing and we're almost done with this one now. How could I get to where those trues are at? How could I get to where, because is.na lets me see, is something missing? So that just says, yeah, those are missing. Those things are missing. So how could I get the positions? So like, if you want to find out the positions of the trues, this will return. Could you count until it hits false? Oh, we wouldn't want to count. What does this code? Can you decode what this code? What will this code return right here? So is.na is going to tell me if something is NA. It's going to say position 1 is NA, position 3 is NA, or true, false, true, because this is NA, this is not NA, this is NA. So what will which return? If I run which around this, what will which return? So if you take a logical vector and run a which around it, what does it return then? So that's the key right here to this, is that if we have a logical vector and we use a which around it, it's going to return the what's of the what's. If we have a logical, not 1 and 0, good guess, Parker, 100 points, good guess. Which returns, and let's type which, and this will give us a hint right here. So which returns the what's of the what's, which it says it a little bit differently than I do. Maybe I should start using that language, but you say indices to someone, they're like, what's an indice? You're like, well, it's a position. Well, kind of, it's going to return, so the position. So what will tell me, you're on the right track, Parker, great job. So what will be this code's return when I run it? So look at what the inside of this is displaying. The inside of this is this. So if I run which on this, what will it return? It's good practice. You're like, oh yeah, returns the positions of the trues. So what's the code going to return if I run all of line 97? All of line 97 will return what? Because the inside of this is just, and this would not run if I do it this way, but the inside of this is this. So that's what the inside is. It's just that. Looks more complicated, but so knowing that the inside is this, what will this return? It's going to return the positions of the trues. So the positions of the trues are what? Don't worry, take a shot at it. You got this. 100 points, right or wrong. The positions of the trues are what? So what are the positions of the trues? Close, Parker. Close. 100 points, Parker. You're on the right track. So that would be which. That the code you've written right there would be as.integer. Now, trues and falses are 1s and 0s. So that would be if you ran as.integer on it. Well, wait, you ready? So let me ask you this, Parker. I think you'll get it. What position is this first true in? Just answer this with one number. What position is that first true in? So if you run which in a logical vector, it's going to tell you the positions of trues. So what position is that first true in? What position is this second true in? What position is that second true in? What position is that second true in? Ah, Parker, you know what? I had this ready for you, Parker. You get, oh my gosh, that's the code. Well, Parker, I had it ready for you. 500 points. That's what I was typing in the background. 500 points. Little randomness, Parker. You got it right there. It's going to turn 1, 3 because those are the positions of the trues. So if you do a which dot or is dot NA, it tells you if something is missing. If you put a which around it, it tells you the position of the trues. And that's what we like to see right here when you're like, oh, okay, this tells me if something is NA. Is it NA? And then we find out where are the positions of the trues. You got it, Parker. There you go. That's the steps. Parker, thank you so much for practicing. That's most of number 2 done. The simplest way to handle the missing values. So we go to those positions and recode them. But I would take here, great job. Yeah, I would store these as positions. And then I would go to whatever vector you're looking at. I'd store right here into those positions. And then I would take and store the whatever mean or median. I think you're doing median. And then you need to make sure to do na.remove equals true. But make sure to do na.remove equals true on it. Well, that's got it. We're going to head off. I'm going to grab some more coffee. Parker and everyone, great work right here. Little hacker man to end the day. Hacker man out. More coffee time. I'll be back here soon.